Welcome to solverfy.
This is the answer to Chapter 26, problem number 37 from the Smith Organic Chemistry textbook. This problem is describing a Heck reaction that forms product E only and not the expected product F. And we are asked to account for this by drawing a stepwise mechanism, and then also to talk about the third step, the stereochemistry of the third step of the mechanism. Okay, so the first thing that's going to happen is going to be oxidative addition. So I'm going to just abbreviate that as OA. So the palladium will oxidatively add. So the palladium adds there, the iodine is still there, and then the two ligands. Okay, so they're going to look like that. So then the cyclohexene comes in there. Okay, and so we get a syn addition as our second step. So now the palladium is here. Got to move it down. Okay, so the palladium is here with its two ligands and the iodine. Okay, and the phenyl ring will be here. Okay, and so now the third step that's going to happen here is going to be a syn elimination. So actually going to move this over a little bit. Okay, so it's going to be a syn elimination. So basically we have two hydrogens here on this carbon. So we have these two hydrogens on this carbon, and then the other carbon that has the phenyl ring on it only has one hydrogen, and that hydrogen is necessarily on the dash there since the phenyl ring is wedged. And so since we need to do a syn elimination here, it's going to have to be this hydrogen that eliminates. And since there is no cis hydrogen on this side, that is why we don't get that product F that we might expect, and we only get product E. Because this is a syn elimination, the hydrogen has to be cis to the palladium, and the only available cis hydrogen that can eliminate is the one that I've arrowed in red there. So that is the answer to part B of this problem. And then the rest of the mechanism is just this. Okay, so we've done that syn elimination there. That's product E that we get. None of product F, and then we'll also produce this palladium species And so we regenerate our palladium catalyst by reductive elimination. So I'll just call that RE. And so that gets us back to our palladium catalyst. And it's also going to give us hydroiodic acid. Okay. And so those are the four steps of this mechanism. So we have oxidative addition, then the syn addition to the other substrate, then the syn elimination, which again accounts for why we get product E and none of product F. And then lastly, the reductive elimination regenerates the palladium catalyst that we need. Okay, and so that is the answer to chapter 26, problem number 37.